it's all connected. Sound and motion, it's all connected. The frequency of a wave changes relative to its source. The observed frequency, f, equals 1 plus the change in velocity over the speed of sound, times f of o, the frequency. Therefore, the change in frequency, or f, is equal to the change in velocity over the speed of sound. And it's all multiplied by the emitted frequency, f of o. We've done it. We've done it.
So, Doppler discovered
that when standing in a fixed position,
the frequency of a wave traveling past him changed relative to his position.
he created two formulas describing this phenomenon.
We're going to test this theory.
This is how he did it. He played a single pitch from a moving vehicle and observed the sound as it passed. When listening, he could clearly make out the change in pitch as it approached and passed him. Here's an in-car view, and you can clearly hear that the sound never really changed.
We set the note to C natural, the sound of the car horn,
and recorded the car passing from different angles.
We noticed that as the car approached, the note went from C natural to C sharp, and then as the car was even with us, it went back to C natural, and finally to B, which is also known as C flat, when it passed us.
We proved our hypothesis by using the first formula that Doppler came up with.
we set the velocity to 22.352 meters per second, which is 50 miles per hour. The note we used,
As I said earlier, was C natural, which has a frequency of 523.25 hertz.
the speed of sound is 340.29 meters per second, and using the equation, we could determine the changes in pitch.
The number we came up with was 554.37 hertz.
Which is C sharp, proving that the frequency increases as the car approaches.
Now, using the other equation, we proved that the frequency decreases as the car passes. We used the same numbers as before and discovered that the change in frequency was 29.37 hertz, showing that the pitch decreased from C to B, otherwise known as C flat. So, what does all this mean? What is the significance of the Doppler effect? Well, there are many different interesting applications, but the two most important applications of the Doppler effect concern themselves with astronomy and with radar. By using the formulas I created, you can calculate the velocity of a moving object based on the frequency of its wavelength. As it concerns to astronomy, you can calculate the velocity of a moving star as it rotates around its galaxy. As I said earlier, everything is connected. Thanks for watching. This is Christian Doppler, signing off.
Like we always do at this time, I go for mine, I get to shine. Now throw your hands up in the sky.